Okay, so in this video, we're working on polynomials now, okay? And so what I'm going to do is I'm going to pick up and work on kind of maybe the most complete one. So let's do 34. I think you can go back and do 33 on your own. So 34 asked you to solve this equation. All right, so it was degree 4. What that tells me is I need 4 answers at the end, okay, but only 2 nice ones, 2 nice ones in order to be able to finish the problem, okay? So I'm looking for 2 nice solutions, and this was one where they didn't give me a hint at all. They said use the rational zero theorem as an aid in obtaining the first couple of roots. So the possible roots come from the 18 and the 1. So it's plus or minus 1, 2, 3, 6, 9, and 18. And then happen to have a 1 in the beginning, so that's plus or minus 1. But if that had been a 2, you would have had 1 and 2. Okay. So since you're only dividing by 1, this one turns out to have these as the possible rational roots. We need 2 of these to work. So we need 2 of these to work in order to finish the problem, because that'll get us down to a quadratic. So that's when you come in, and this can take a while. It just depends on what the roots really are. And so you just get in there and get busy. So be working that out. Ooh, this is not looking good at this point. Okay, I'm abandoning that. I can tell I'm looking for this being a remainder of 0, and that ain't going to happen. So I'm going to move on. So I'm going to come in and try -1. I usually kind of go pretty systematically unless I notice a pattern of some sort. Okay, looking a little better. Okay, looking a little better. Let's see now. Oh, looking good. So that is going to be a -18, but when I multiply by -1, I get a positive 18. So that one, this, I'm going to circle in black. That is one that works, okay? So now I can keep going from there using the remaining numbers. And -1 might be a double root, so I might want to try that actually. Sometimes I don't do that, and then I forget that that could happen. Okay, so that would be +5. That would be -58. No, that's not going to work. Okay, so I know I don't have a double root. There's not multiplicity 2 or anything. So I'm going to go back to these values right here, okay? And I'm going to start testing, but I'm going to test from there now. Don't need to go back to the beginning. And I'm going to keep going. So 1 and -1, I already know -1 works. Now I'm going to go to 2 and -2, 3 and -3. So let's try the 2. And this process can just take a while. So I'm trying to be very authentic about how it feels. Uh-oh, that's not going to work. Let me try -2. Okay. 151. That's going to be, that's not going to work. Once it doesn't work, then just move on, okay? So I'm finding the negative ones, though, seem to have a better shot at it. So I might try a -3 instead of the +3 first. Okay, so these are different signs, so I'm subtracting. Nope. All right, if I change that to a +3, let's see. Nope. Okay, so neither of those worked. Okay, what was next? A 6, I think. 6 and -6. Let me try the -6. I liked the way the negative was kind of knocking out something at this point. So that was a -10. It's a +60. -3. Oh, good. +18. Yay. Bingo. All right. So that's one. All right. So see, way back at the beginning, we had that 1 worked. Then we tried -1, 2, -2, 3. There's nothing wrong with our process. I tried -3 and 3. Just took me a while. But you see how now I only have 3 numbers. See, it was degree 4. If I found 2 roots, there's only 2 left, and that means that this is going to be a quadratic that I'm trying to solve. So you could give factoring a quick try, x squared minus 10x minus 3, but that's not going to factor, is it? Okay, so I'm going to give that a quick try. Then I'm going to go in and say, well, A is 1, B is negative 10, C is negative 3. Let's see what we get. Okay, and so we wind up getting a 10 and a 2, but don't make that a 5. You have to wait. It's 100 plus 12 Okay, so let me take that 112. That's kind of unfamiliar to me. Wow. Okay, so that was 1, 2, 3, 4 2s and a 7. So there's a pair of 2s, there's a pair of 2s. So this is going to wind up being a 4 out in front of the square root and a 7 underneath. Okay, and then finally, I'm going to look to see, since 10, 4, and 2 are all divisible by 2, I'm going to wind up simplifying this. 2 goes into 10, 5 times, 2 goes in there, 2 times, so 5 plus or minus 2 squared is 7. So the question was for you to find, okay, all the roots, solve the equation, so you got to get all the roots. So let's put it all together. We had -1 and -6 when we were doing the synthetic division, and then we got the 5 plus 2 squared is 7, and then the 5 minus 2 squared is 7. So it would be those 4, okay? All right, did I do that right? 5 plus 2 squared is 7 on that one. All right. Okay, so that's kind of the typical process for it. Then I give you one with an imaginary number to work out, but it's not a hard one. So I don't think I'll bother doing that one. This was number 34. All right, let's go ahead and go down to a different type of problem. Let's get into some graphing. I'll tell you what I'll continue doing on this video before I go to graphing. Let's just get the others set up, get the plan, but then you can finish them. So let me go back to 33. 33 said 5 is a 0. Find the others. And on mine, that what I needed to, the function I was given was this. Okay. And so 5 was a 0, so it would go in the box, and then I would put those numbers. I know I'm going to get a remainder of 0, and then here, here, and here I'll have my A, my B, and my C, and I can use that with the quadratic formula. So that's kind of the setup on 33. On 35, we're told I is a 0. And we have the function P of x equals x to the 4th minus 6x to the 3rd, 7x squared minus 6x plus 6. And if I is a 0, I can go in the box. Okay, and so what you'll do is you'll do that. Let's go ahead and do that. 1, and then that's an I. Okay, and then you'll take and multiply I times 6, -6 plus I. So I usually have to do a little scratch work to make sure I get that right. So that's a -6I and a -1. Okay, when I add that, I get 6 minus 6I. I have to multiply that by I. So that's going to give me 6I minus 6I squared, which I replace with a -1, just like I did that. So that'll become 6I plus 6. So that's going to be just 6I there. And then I do I times 6I, and that's 6I squared, which is -6. And I knew that had to happen. Okay, now I'm not going to do the whole other one, but I did want to tell you, you know, when you have these imaginary zeros, if you know one of them, you know the conjugate has to also be a 0. And so that's going to be what you do now. And then you'll wind up getting a remainder of 0 right here. And you'll have your A, your B, and your C. And you can find the other two zeros for that polynomial. So that's kind of the portion on the polynomial test where you use an algebraic process to either find the zeros of a function or solve a polynomial equation. Okay. Next video, we'll do some graphing.